Radio was born with a gunshot. From the attic of Villa Grifone in Pontecchio near Bologna, an electromagnetic impulse crossed the hill of the Celestini and was received by ground antenna over 2 kilometers away. The gunshot confirmed that the 3 dots of the Morse signal had arrived. It was 1895, and for the first time telecommunications did not require telegraph cables and wires. The wave surpassed physical barriers connecting 2 non-visible locations. What was separated by distance became united by radio waves. The entire world could connect.
Guglielmo Marconi era una personalità molto complessa e soprattutto molto intelligente, attratto dalle
internazionale di comunicazioni senza fili.
Marconi continued to transmit over ever greater distances. In London, radio waves connected one bank of the Thames to the other, then the 2 shores of the Bristol Channel. In 1898, the British Regatta at Kingstown was the first sporting event to be broadcast live as updates from the sea reached the mainland. From her summer residence on the Isle of Wight, Queen Victoria received information via radio from the Royal Yacht. In 1899, Marconi transmitted across the English Channel. It was now time for the greatest challenge of all, considered impossible by the day's scientists: crossing the Atlantic Ocean with radio waves, from England to Canada, from Portune in Cornwall to St. John's, Newfoundland.
Questo suscitò grandi risate tra i
So just a few minutes of that. It's a 16-minute video. You can check that out, and we'll probably be bringing that up again next month. But pretty neat stuff there. Let's see. We have the same few people here. Appreciate everyone joining here. Welcome to the Elmer session. It's just a general Q&A about ham radio STEM topics. So if anybody has any projects they want to update us on, or any questions you might have, let us know. Otherwise, I am more than happy to bring up a few stories and articles. Let me see. Pretty neat story here. Capacitor plague of the early 2000s. Written by Maya Posh on the website hackaday.com. Somewhere between the period of 1999 and 2007, a plague swept through the world, devastating lives and businesses, identified by a scourge of electrolytic capacitors violently exploding or splurging their liquid electrolyte guts all over the PCB. It led to a lot of finger-pointing and accusations of stolen electrolyte formulas. In a recent video by Asianometry, story is summarized. Bad electrolyte in the faulty capacitors lacked a suitable depolarizer, which resulted in more gas being produced, ultimately leading to buildup of pressure and the capacitor ultimately failing in a way that could be rather benign if the score top worked as vent or violently if not. Other critical elements in the electrolyte are passivators to protect the aluminum against the electrolyte's effects. Although often blamed on a single employee stealing an incomplete Rubicon electrolyte formula, the video questions that narrative, as the problem was too widespread. More likely, it coincided with the introduction of low ESR electrolytic capacitors, along with computers becoming increasingly more power hungry and thus stressing the capacitors in a much warmer environment than in the early 90s. Combine this with the presence of counterfeit capacitors in the market and the truth of what happened to cause the capacitor plague probably involves a bit from each column. So more on his channel, YouTube channel, Asianometry, for a 22-minute video on that. I know I did early PC work in my early youth, and I remember capacitors. People always talked about these bulging capacitors and things like that. So it's interesting to hear that wasn't just something naturally. It was unfortunately a kind of a man-made issue, unfortunately. All right. Anyone else? Comments, questions? Let us know. Let's see. Same few people here. We've been talking about the SI 4732 based software-defined radio has been pretty popular in the media recently. 30 or depending on where you get it from. AliExpress is usually the case, but it's $20 or $30 or so. Your mileage may vary, and there's plenty of YouTube videos showing reviews of that radio. So go check that out. It's if you can see my screen, it's basically just a small form factor radio and shortwave radio, shortwave bands, SMA connector on it. But been pretty popular, and sounds like it's only getting better and better as newer firmware and software comes out for it. Let's see, we have 50 or so minutes. Anyone else? Comments, questions, anything else so far? Let us know. Again, we thank John Portune for being in the chat here, W6NBC, and giving us a presentation this evening. We did initially mention that this was going to be a presentation on the RF snooper probe. But he gave that same presentation to us back in September of 2023. So we are thinking of maybe changing the presentation that's being given here this evening to another presentation of, also by John though, plastics and adhesives for ham projects. Not all hardware store plastic materials and glues work well in an RF environment, such as for building antennas. Learn the practical do's and don'ts, plus some interesting, simple molecular chemistry. So, yeah, stuff we really don't often talk about. So, you thought that might be of an interest.
Good. We'll do that one.
Yeah, that'll work.
I think it's a useful topic that not many hams know about.
Okay, good. Absolutely. Yeah, there's some of the finer engineering that we don't always look into and understand besides some of the basic RF and electrical. And yeah, it's always good to know some of this other chemical and other stuff. So very cool. Anyone else? Comments, questions, anything else? Let us know. Again, this is an hour or so long. We have 45 or so minutes. If anybody has comments or questions, let us know. Otherwise, I'm more than happy to maybe play another video or read another article or something. But if anybody has anything, this is the time.
I have a little question for you. How
Please.
many of you out there spotted the two spoof articles or two spoof items in the latest QST? It's the April issue, you know.
Let's take a look.
Anybody spot them? I'm glad to see that they have lightened up a little bit back in Newington, and there are two spoof items in there which you may not have caught. Keep going.
As an incorrect or?
No, they're spoof articles. They're April 1st.
Oh, I see. Okay.
Just keep turning pages and we'll come to it. Very clever, I thought they were.
All looking good so far. Kosher so far.
There it
looks
is.
like. Oh,
Back up. Just there it is. Turn your vertical antenna into a rotatable beam. This is a very clever article. As you can see here, that's a magnetic mount on top of a car. And he's taken a piece of carbon fiber tubing and cut a slit in the side of it and slipped it over the 19-inch whip, and claims all sorts of wonderful performance because of it. And when you read it, it reads very well. You think, oh, that's a neat idea. You can turn the page if you want to. Yeah, it's very, very well done, and narrow bandwidth. But when he got down here to the on-the-air 20-meter performance, he talks about doing the same thing with a 20-meter dipole. And I read that. I said, boy, how's he going to hold that carbon fiber tube up around a 20-meter dipole? That's kind of heavy. How's he going to hold it up? And so I didn't think much about it. I was going to go back and read it more carefully later. And then I went to bed, and I was waking up in the morning, and this thing kind of jumped into my mind in that kind of foggy state your mind is in the early morning. And I thought, wait a minute, I wonder what issue of QST this is. And so I quickly got up and I scanned down to the bottom, go down a little bit lower, just scan down a bit lower. There it is, April 2025. I said, they've got to have put a spoof article in there. And
Yeah.
once I realized this is not legitimate.
wow.
Anyway, keep on going here, though. But I didn't realize, and my good buddy W6OEK said there's another spoof in the magazine, but it's not an article. It's a new product. So keep on going. See if we can find it here. It's called the Snappy Learning Key.
Okay, let's see if I can.
Whoops. There it is. Scan, move down. Can you move down? That's really clever. That's a key built on a mousetrap, so that if you send the wrong characters, it reminds you by snapping you in the finger. That's another April 1st spoof article.
Wow, that's cool.
I'm going next a couple of days when I talk to the editor of QST, who I know quite well by now, Becky Schoenfeld. We talk every month about articles that I might be going to write for QST or on the Air magazine. I'm going to compliment her for allowing these fun articles in, because I think for a couple of years QST got extremely straight-laced and eliminated all of the fun stuff. There used to be a lot of fun stuff. You used to have Jeeves cartoons and Wouff-Hong and stuff and always a and
I was
always
just about to ask you that the Wouff-Hong it's like a Halloween-based thing, isn't it, or something spoof?
I don't know the history of Wouff-Hong. Does anybody know? What is the Wouff-Hong thing? Honor of Halloween, huh?
Yeah, I guess at least on allbands.com. Here, let me see if I can find. There's it's called a ceremony. Wouff-Hong ceremony. Very old, but I'm guessing kind of spoof in that same kind of manner. Let's go back to that other article here. Honor of Halloween, the word of the day, an object designed to strike terror in the hearts of any amateur radio operator, whoever called CQ. Of course, they're calling out dreaded Wouff-Hong. Page 11 of 1930s Radio Amateur's Handbook, it reads, the Wouff-Hong is amateur radio's most sacred symbol and stands for the enforcement of law and order in amateur operation. Origins can be traced back to none other than Hiram Piercy Maxim, W1AW, co-founder of ARL, where he wrote different articles. He later used the term Wouff-Hong to refer to a make-believe piece of ham radio equipment used to keep bad operators in line. A tongue-in-cheek warning to the amateur radio community of importance of always using best practices when on the air. There's a picture of it. I think I've seen it before, and it didn't really make sense what that was. Yeah, it was just a weird stick thing here. So, I guess they had it in that. But, yeah, a term that I barely heard years and years ago, and wasn't sure if it was a real thing or not, but it's apparently not now. So,
well, there used to be a regular cartoon feature in QST called Jeeves. He was a butler, and he did funny things, and but that most of that disappeared here a few years ago. I guess they felt that wasn't erudite enough for QST, which is there he is. Yeah, there's.
That's good. We could take. We don't have to take ourselves completely seriously. I know that there are in QST. There's like a retractions or there's a sections to correct thing. Maybe someone will come in here and correct this. This isn't a real thing. Well, no, it's not. It's April Fools. But it's glad that we have a sense of humor still, at least. So. Ham radio cartoons. Wow.
Yeah, they were more popular back a few years ago. Like you say, I don't think we should take ourselves that seriously.
Yeah. I did see there is a Japanese. There's a series called manga, or it's basically there's a ham radio based like Japanese anime. I'm trying to find what it is here. But it's a pretty interesting PDF. Let me see if I can find that. But yeah, anyone else? Comments or questions? We have just a few, 8 or so people here still. Anyone else? While I can bring up this other thing here. Let us know. Oh, sorry. Go ahead, John.
Well, I had some pretty good success with a couple of spoofs in QST. My favorite one, which they never did publish, it got published in Nuts and Bolts, the little magazine on the perverse mind of drop nuts and bolts. You know, if you drop a nut or a bolt and it falls on the floor, it seeks, as soon as it falls, it seeks out a place to go where you can't possibly find it. And although if you can watch it when it falls, it knows that you're watching. Therefore, it doesn't know. It knows that the jig is up, and so it doesn't go hide itself. Or if you're up on a high tower and you're installing an antenna, and you drop a big, heavy 3/4 inch bolt or nut, it'll fall, and it has several choices to make. It either will fall in a dense flower garden where you can't possibly find it, or if you're in a parking lot, it'll seek out the hood of the most expensive car in the parking lot. If there's a classic Cadillac or an Mercedes down there, it'll fall right in the middle of the hood of the of the Cadillac or the Mercedes and make a big dent.
Occam's razor, and they'll have a mind of their own, it feels like. Yep.
Oh yeah. So I wrote a recent article and sent it off to Nuts and Bolts magazine, and I got a note back from the editor of the magazine a couple of days ago saying they're going to publish it in the next issue. About the perverse mind of cables, ropes, string, yarn, anything like that. If you leave it alone, it has a natural tendency to snarl up, and if you pull on it, it'll pull into a very nasty snarl. That's why I call my hose out in the backyard, I call it Anaconda, because it's a snake with a mind, and as soon as you give a yank on it, it snarls up into a nasty snarl. So inanimate objects, or even animate objects like that, definitely have a perverse mind.
Yep.
Of course, my most famous spoof was one that they didn't publish, and I'm surprised that they didn't, but that was back in their very straight-laced day. And you can find it on my website. If you go to W6NBC.com and just scan down, you'll find the article on neodymium spray. It's a spray that you can get, and you spray it on coax, on the outside of coax, and it eliminates SWR. Of course, it's a spoof, but I think the best piece of spoofing I've ever written. So if you want to have yourself, there it is, neodymium coax spray. If you got a couple of minutes, you might want to play it. Turn the sound on and play it.
Let's see, is there sound? Let me see here.
You got to play
I just downloaded the PDF, or just the PowerPoint. Was there audio in the PowerPoint?
Yes, it's animated.
Okay, let me see if I can. I've not done too much audio.
Before you bring up before you turn the sharing on or whatever it is, you have to enable sound.
Try that again here.
As soon as you click on share, somewhere up in one of the major boxes there's share sound.
Yeah, I'm just not getting any audio from the PowerPoint itself. I'm just trying to find that.
Did you get that off of my website?
Yes.
Well, you should get the sound,
Okay.
because that's a little video.
Okay. Oh, I see here now. Yep. Let's see if I can.
At the Oropaea.
Okay. Let me see how I can do that here real quick. Yeah, anyway, well, I'll try to futz with that. If anybody has anything else, a few other people on here, I'll see if I can play this quick presentation here. But anyone else, comments or questions, let us know.
Oh, this is the PDF. You're downloading the PDF. Yeah, that's.
Oh, I have. It's the PowerPoint, but it's. I'm just trying to figure out how to. Let me. I should be able to share the audio here in a second.
The PowerPoint doesn't have audio on it. It's the thing you download from the homepage of my website, W6NBC.com. Keep coming. Go down. Now.
Oh.
That's
okay.
it. Now try that.
Right,
click on the arrow.
Grab this. Put this in Chrome. Yeah, sorry, it's just how. Let me make sure that's. It's unfortunately just how Chrome works here. It should be working now.
At the Europäische Elektromagnetische Regierung, the EER, in Ehrenhausen, Germany, a researcher in magnetic domains has developed a revolutionary new product that holds out major promise for the radio communications industry worldwide. Axial neodymium hydroxide spray, or Nihox Orange, as it is to be marketed, when applied monodirectionally and longitudinally to coaxial cable greatly reduces SWR, a traditional burden to the RF industry. This curve shows the reduction of the reflected wave when it encounters a neodymium hydroxide coating on the outside of the coaxial shield. The SWR reducing effect was first observed by Gerhard Friedrich Hohm in 1987 while working as a technical consultant for Apex Corporation in Deadwood City, North Dakota, on the coatings used for magnetic recording media. He noted that if rare earth particles were combined with the conventional magnetic iron oxide particles and applied in one direction longitudinally to the coaxial cable, that the distributed incident S11 reflection of the standing wave, SWR, was reduced, though in his paper in the prestigious British science journal Nurture, he noted that the observed effect was very small. Late last year, however, Holmes's preliminary discovery became a practical reality when physicist Wilhelm Klang of the EER reacted finely divided powdered elemental magnetic neodymium, widely used in the manufacture of powerful rare earth magnets, with unstable praseodymium tetrahydroxide. The resulting RF active compound ND3OH4 generates a high-intensity, circularly polarized pointing field that nearly totally eliminates SWR by reorienting the magnetic domains of the S31 reflection coefficient of the standing wave. The product will be marketed in an aerosol spray with a specialized differential nozzle that monodirectionally orients the micromagnetic particles. A fast-drying conformal polyacetyl polymer propellant dries almost instantly, stabilizing the orthogonal fields which blocks the reflected wave. Major chemical manufacturers worldwide are setting up facilities to manufacture the product. The product is now only available in limited production by Cataleptic Adhesives GmbH, New Mexico, but will likely soon be marketed widely. Complimentary trial size samples are currently available to the general public. For a trial quantity, go to Helen Waite or Larsen E. Enterprises, Krankenhaus, Germany.
Very good. Very good, John.
I was filled with all sorts of spoof stuff.
Very cool. Very cool. It's good to see.
Anyway.
That is good to see. Yeah. That is good to see. Yeah, absolutely.
Well, now that they're
Oh, go ahead.
now that they're back putting spoof in the magazine, maybe I'll think about writing something new. So if any of you have a good idea for a spoof, send it to me.
Yeah, absolutely. Yep, we had Alex, one of our members, KS0E, in our YouTube chat. We were streaming this on YouTube. He was saying he thought it was some sort of secret society. So fooled him there for a moment. So that is all right. But deadpanned given there. Very cool. All right. Anyone else? 6:30. Let's see if anyone else has joined here. No one else has joined just yet, unfortunately. But we have plenty of things we can talk about. Plenty of things that have come up. Let's see. I'll just go through some of the recent presentations that have been given at some fairly large conferences. Quite a few, actually. Starting with Hackaday.com, the Hackaday conference. If you're not aware, Hackaday is a blog about electronics, STEM, STEAM, and all sorts of stuff. So they had a SuperCon presentation, so all sorts of pretty cool talks given here. Experimental amateur aircraft and innovation, custom firmware for 3D printers, KiCad projects, adventures in reverse engineering a commercial coffee maker, going into deep water logic for Pico Pi, some stuff there. Receiving microwave signals from deep space. So this goes back 9 months. I thought this was they had something more. Oh, they did have more recent under their live page here. Hackaday Europe 2025. Here's the new stuff. Vectors, pixels, plotters, Dutch hacker camps from the past and the future, half-size hacking, 0.05 inch matrix boards under the microscope, decoding software behind pen plotters, all sorts of pretty heady, pretty cool topics here. So if there's any interest in that, head over to youtube.com/hackaday. Plenty of stuff on there.
Yeah, they're a pretty good site. I get some interesting ideas from them.
Good, absolutely. Yeah. They've done a pretty good job of kind of combining a lot of the communities, it seems like, over time, whether it be ham radio or whatnot. So they are an amazing blog. Let me just bring their page up here. There it is. Yeah, they have a great podcast and lots of great articles, often radio related. So lots of cool stuff there. So if anybody's ever interested, hackaday.com, pretty cool blog to read. Anyone else? I certainly have 100 other tabs I can open up here, but anything else, let us know. Another group here, not the RCA that we all know, but different RCA, Radio Club of America, founded in 1909, oldest, most prestigious group of wireless communications professionals in the world, according to them here. So, Radio Club of America, and it's they have a lot more professional engineers, broadcast engineers, so they're able to be given a lot more professional presentations. It's the origin of the National Interoperability Field Operations Guide, NIFOG. Another presentation, 3 events that shaped their career, from Crystal Radio to Telestar Antenna, space communications at Bell Labs, then and now, SETI updates. So this was just another recent set of talks that was given over for this group here. RadioClubofAmerica.com. Or .org, excuse me, for more information on them. All right, let me just take a drink here. .640, we have another 20 or so minutes, and then John will be giving us a presentation here. Slightly different than what was announced, but it will be new to us, so it will be pretty good. So, anyone else? I can scroll through a couple of my tabs here. If anybody has anything, GNU radio projects, they have a bunch of presentations I can list off. Mark a friend of the club, he is putting presentations online for the NA0TC club. 285 Tech Connect. So if you've ever heard us mention the 285 Tech Connect and Tech Fest, he's been recording those presentations and putting them on his YouTube, so check that out. Mark, EHR. Some of the fairly normal presentations that you'd expect. WinLink, remote operations, solar cycle updates, HF radio questions, but plenty more. So check his YouTube out as well. Mark EHR. I think he's KE0EHR. Anyone else, though? Let us know. let's see, another amazing podcast, really professional actual engineers. This Week in Radio Tech, they did start on twit.tv, just like Hamination is on there as well still. But Twirt, TWIRT, This Week in Radio Tech has moved on over to their own network, essentially. But really amazing broadcast engineers being able to just show some of the stuff they're doing here. So let me see. This is moving 8 radio stations on Maui with Russell Lafferty. So I'll just play a minute or so of this here.
And sometimes there's clouds up there, but so often, we'll see a picture in a few minutes, so often the clouds, if you're on Mount Haleakala, where are the clouds?
Below you.
Yes. That's amazing. That's why they put the observatory way up there. Let's see what's next. You know, that looks like the Martian surface. All right, tell me about this building. We're going to have a video tour of this building in a few minutes.
This is our transmitter.
It would help. Let's see.
Building right here. That is the end where you come into it, where you come in from the highway.
Yeah.
Yeah.
All right, so we're going to have a tour of the tower on the right. Has got a number of FM antennas on it.
You can see one on the top right now.
Yeah,
on the top right.
Yeah.
The biggest one of those dishes is about 24 feet.
Oh my goodness! As far as we can tell, the big dishes
they are still being used.
They are?
Found out yesterday. Yes.
Well, we couldn't find the equipment that was running because all the equipment we saw was turned off.
It's running into the equipment in the smaller equipment in the other room.
Oh, okay. Okay.
It's a relay from the Big Island to Oahu.
Radio station stuff. I see some FM transmitting antennas.
There are other stations here besides us. I think there are 2 or 3 groups. We have an antenna here. We have antennas on the far side that you can't really see from here yet.
And I see a little microwave.
That is our signal getting up from the studios in town.
That's our 11 gigahertz ubiquity.
Yes, it is.
Right there. We have a couple of Nautel NV5s. These are what?
Hawaiian Public Radio.
Hawaiian Public Radio. All right.
They come this way. They are back to back, combined into the Shively Labs combiner.
Oh, there's the okay.
There's the combiner. There's the out of here.
That combiner looks a little oversized, but it does not get hot.
Does not.
And then they go out
on the 3-inch coax.
Pretty big coax. Okay. All right.
So that's just a few minutes of that. They have they're at episode 700 and something now, about hour-long episodes, either audio or video. So I would highly recommend checking them out. If you look at their videos and their popular videos, one of the top ones is Bob Heil, as you would expect. So Bob Heil, late great. So lots of really cool stuff there. Radio in Canada, voiceover mics, audio processing, World Trade Center transmissions, Radio Caroline, audio forensics. So a lot of cool stuff if you're interested in that. Anyone else? Let us know. I see there's only just 8 or so still people in here. Anyone else? Comments, questions, anything else? Let me know.
What's the one on Radio Caroline?
Yeah. There'll be probably let me bring up something here.
I have a kind of an interest in Radio Caroline because I was living in the UK at the time the pirate radio stations came on. And one of them was called Radio Caroline. I'm wondering if that's the same thing.
It is. I'm going to see if I can find a pretty interesting video on that, though. I'll play this here real quick, though, while I'm bringing that up.
Coming up on This Week in Radio Tech. Well, I'm here, of course, but you know who else is here? Rob Ashard and Nick Jackson. They're on a boat. They're on Radio Caroline. They're on the Ross Revenge boat off the coast of England. Coming to us live on This Week in Radio Tech for a look at Radio Caroline.
I was on that boat.
I'm trying to find, I guess
This Week
on our YouTube channel, I did play it. Let me see here. 2 British presenters interviewed one of those DJs. Let me bring that up here because that was pretty funny.
Another monopoly.
So what is this site, Darren?
Which one?
Ron? What is this radio? Where are you finding this information? What is the website that's got all this info?
That other one was This Week in Radio Tech, TWIRT. And it's I guess the guys from Queen's Network, if you've maybe heard of them from the past. They actually host them. Let me see. They probably have their own. thisweekinradiotech.com is their full website.
Okay.
Yeah.
Yeah, I had a lot to do with the pirate radio when it first came on in the UK because I was living there and I was involved in broadcasting at the time.
Oh, very cool. I got, let me see here. A DJ that was on there can give a first-hand account here. See if this plays.
Yeah, very much so, yes. Congratulations on your 100 years of being together, by the way. Well done.
Tony, to put our digital decade into context,
Yeah.
how many years have you been broadcasting?
60. On July the 25th, it'll be 60 years. Yeah, I started in 1964 on Radio Caroline.
Yeah.
July the 25th, 4 o'clock in the afternoon.
Wow.
And been talking nonsense ever since. Really.
So how old were you?
How old am I? 81.
No, how old were you?
Oh,
sorry?
I wasn't 81 in 1964, no. I was 21. 21 years old, yeah.
So cool.
Yeah, I'm 81 now.
Because I'm fascinated by Radio Caroline. It must have been so... Where were you broadcasting from?
We were 3.5 miles off the coast of Frinton in Essex, where we were eventually shipwrecked. Actually, we were shipwrecked in a 10-force gale.
Is that actually showing or presenting? I don't know if that was actually presenting. Let me try that again here. It's a pain doing this stuff here.
Broadcasting from?
We were I was 21. 21 years old, yeah.
So cool.
Yeah, I'm 81 now.
Because I'm fascinated by Radio Caroline. It must have been so... Where were you broadcasting from?
We were 3.5 miles off the coast of Frinton in Essex, where we were eventually shipwrecked. Actually, we were shipwrecked in a 10-force gale, and nobody came out to see us.
That's incredible.
Except the local police force, who said how much they were enjoying the programmes, took us back to the police station, gave us a cup of tea and sent us home.
Wow.
But it was, 3.5 miles off the coast of Frinton. There was a whole load. Initially, there was Radio Caroline, then Big L Radio London. That's the one I really loved. That's the one I went to. And then we had Swinging Radio England. It was like an invasion fleet. I mean, Frinton on Sea, where nothing ever happens. I mean, they couldn't believe what had happened to them.
Because until Radio 1 came along, there was no sort of pop music. There was no young...
So just a quick take on that. Yeah, anyone else? Comments, questions? We have another 10 or so minutes. But do check out a history of Radio Caroline and all the stuff there. Lots of stuff. Lots of cool stuff to see there. I hate how Chrome presentations work. Sorry about that if presentations weren't working over the Google Meet here tonight. Anyone else? Comments or questions? Let us know. We have another 10 or so minutes.
Coming up on This Week in...
All right. Haven't heard from many other people here this evening. Thanks, though, for joining here. We have 8 or so people. We'll be having our presentation by John. Just accidentally left. I think I'll be joining back in just a moment here. There he is. So yeah, we have another 10 or so minutes. If anybody needs a bio break, might be a good opportunity to do so. Hopefully John's not having any technical issues. It looks like he's dropping a rejoin in there. Just see Jerry joined, Ron joined. Thank you all for joining here. Anyone else? Otherwise, I certainly can read an article or two, but to round things out. But we have another 10 or so minutes, as I've mentioned here a couple times. Always check out hackaday.com. Awesome blog to check out. RTL-SDR. If you're interested in software-defined radios, they always have great articles on there. Excuse me. Anyone else? Let me know. I guess back on Hackaday, they have an Etsy-like site called Tindy. So if you ever want to just do some fun window shopping, tindy.com. And you can see some pretty neat projects people are working on, and kits people are selling and making. So if you're ever interested in making a kit and selling it, this is a great website to do so on. Yeah. Just making sure my audio was working. 10 or so more minutes. Let us know if you have any other comments or questions. Otherwise, I can read a last-minute article here. Or let's see if there's any other last-minute video that I can play. Again, we've got plenty of stuff over on our YouTube channel, youtube.com/Denver Radio Club. We've recorded this session in past sessions. John provided quite a bit of entertainment and information this evening just for the Elmer session. Really do appreciate that so far. Got too many things open. Let me see if I can find any last-minute things here. Let's see, Rocky Mountain PBS is always a great resource. What was I going to play on there? Let me see. Now, 4 or so minute video here, Rocky Mountain PBS. As we're getting back into the fire seasons, as some states have not left fire seasons, things are ramping up. So we can't thank enough our Wildland firefighters and their support of our clubs, or just our lives and our property lives, Livingston property. So I'll just play a few more minutes of this here, and we'll probably just wrap things up here. Let me make sure I have this shared correctly. Should be working.
I think a lot of people have doubt. I think a lot of people have doubts in me that this skinny kid from the suburbs can go out and fight these 40,000 acre wildfires. I want to prove them wrong.
I don't see the risk, honestly. Like, it's life. If you die, you die, and it's like, whatever. So this is the S190 and S130 program, and that was just all like how the fire behaves. The S190, which we're still working on, is how you fight the fire. That's how you suppress the fire. That's how you control the fire, and how you stay alive doing it.
My name is Jalen Armstrong. I am going to Metro State, Denver, next year.
Here's a phrase you have to remember if you ever deploy a shelter. Feet to the heat. Wherever the fire's coming, your feet are facing that direction. So if fire's coming this way, you step in, you're gonna turn around, drop, feet to the heat, right? Ready? Deploy, deploy, deploy.
I feel like a lot of people might go and party during college. They might go and, you know, just make stupid decisions, get a ton of student loans. My goal right now is to stay as debt-free as I can, work on my career, and to do wildland firefighting as a summer job.
My name is Lisa Coleman, and I am older. I raised a couple of boys, and they're older now, and I kind of decided, what do I want to do to chase my passions again? And I called here, and I said, oh, am I too old? And Kat said, no way, you're not too old. And so here I am.
Fire is going to be coming. It's approaching from the north, right? And it's going to impact this area first. This is the area that we want to hold. And then we're running a hose line all the way up the hill to the top. Let me know when you have water out the nozzles.
I think everyone's always a little nervous to start in a new environment and meet new people, but we've all gelled together. What I love about it is it's teamwork. And I grew up playing sports, and it was all team-oriented, and so I feel like I'm just circling back to being a kid again.
Rock!
Rock! Bump it out! Bump it out!
This is one of those things that you let the students figure it out, do some troubleshooting, make some mistakes, and so as long as we're always learning, we're getting better. You let them do those things. It takes a little longer. It's easier for us to want to push, but it's better to let them troubleshoot this and figure this out.
Firefighters are definitely a unique kind of person. You don't know your limits until you meet those limits. And I think firefighters every day are always striving for that limit.
Copy, just walking the line.
The risk factor is definitely a big thing for me. I worry about it, but big firefighter losses and everything are studied, and they're a big, big part of training. It's something that I definitely worry about. I want to be able to go home at night, but it is so rare. And honestly, if you aren't a little close to death sometimes, then maybe you didn't even really live.
It definitely makes you appreciate life more. You get called to people's worst day. And it's like that kind of forces you to mature.
I think it's really important that kids know that society shouldn't put you in a box, that you should do what you want to do, and if it's fight fire, come fight fire, and you don't necessarily have to be the lawyer or the doctor or the financial person. If you're happy, you're going to do a good job at whatever you end up doing.
Okay, well, appreciate everyone hanging out here still. Again, do appreciate the efforts of our wildland firefighters. Some come from incarceration and help to provide that volunteer support. So, just a couple more minutes here. We'll probably wrap it up here unless anybody has any last minute things, but in just a minute or so, we'll have John Portune give us a presentation. And the presentation did change. It was on RF Snooper Probe, but since we've had that presentation before, he is now going to be giving a presentation on plastics and adhesives for ham projects. Not all hardware store plastic materials and glues work well in an RF environment, such as for building antennas. Learn the practical do's and don'ts, plus some interesting, simple molecular chemistry. So that is what our presentation will be on this evening. let's see if I can quickly recap in the next 30 seconds what we talked about here tonight. Let's see. SI4732 based mini spy radios. We talked about the QST magazine from April, and that they have some April Fool's articles in there. You'll have to spot those, and appreciate John pointing those out. We talked about a rare ceremony called Wouff-Hong, which doesn't get brought up a lot. It's some of the Jeeves comics from ham radio back in the day. Another presentation, kind of April Fool's that he gave, so check that out. And then I kind of just went through a few groups that gave some presentations. Just check things out on YouTube, quite frankly. Just type in ham radio, and there's hundreds and hundreds and hundreds of videos and presentations. Just ticked over to 7, so we'll throw it over to Jerry.
All right, well, thank you. Welcome, everybody. Thanks for taking the time to jump in here. Just one thing to announce, that we will have a board position open in April. We do have one member that's expressed an interest in filling that position, but it's open. If any member would like to do a board position, they're typically we have 8 board members. They're four members are up every year for re-election or whatever, and then the next year the other 4. So it just cycles like that. So you always have at least 4 people on there with some experience. So keep that in mind. I think that's the only real announcement I've got. John, we appreciate you taking the time to do this. We always enjoy your presentations, and look forward to this one. Give us whatever, not over an hour if you would. I don't know how long you really plan, but
stop and we'll restart back.
We find that even.
Well, come on, why won't it share? Okay, I'm pressing the present. You're hearing me all right, correctly?
I can hear you. We can hear your mouse clicking, but we're not seeing anything.
Okay, I'm doing the present, clicking the present now button.
Should work in Firefox or Chrome or Edge.
Yeah, I'm working in Edge. It says the entire screen. Okay, share.
And if you have 1 or 2 screens, you may not be able to see the chat as you present. So you may just see your presentation, but we'll let you know if something comes up, if that's the case. We're seeing a mirror. We're seeing ourselves now. We're seeing our Google Meet, essentially.
I can't
You might just
bring
be able
it
to
up.
minimize. You might be able to. Oh, well. If you minimize that, PowerPoint might come up, but PowerPoint is a little bit funky in how it seems to work. We're seeing your Word doc there.
Okay, there we are. Are you seeing my desktop?
Yes.
Okay, good. All right, let's go to the PowerPoints down here. Since we're changing topic, I'm going to have to find this one. Okay, plastics. There it is, right there. Okay, slideshow from the beginning. Oops, no, that's not it. Okay, there we are. Are you seeing the opening slide?
Yes, we are. Thank you.
Okay, good. Plastics for ham radio. This might not be a topic that any of you have ever thought much about, but it's a more important topic if you're a builder. If you're not a builder, it's probably not, and yet it's something you might run into one of these days. And here we see a picture of a whole bunch of different things made out of plastic. Plastic, of course, very important aspect of our modern world, and it's an important it's an important issue in ham radio. Ham radio people may think if they're a builder, plastic is plastic. It's all the same. You can do the same thing with any plastic. Well, this is not really true. And if you're a builder, you need to know this information. For example, and this is a kind of an extreme example. Suppose you were building an antenna, and would you build your antenna out of nichrome heater wire, for example, resistance wire? Well, you'd say, of course not. It's got a lot of resistance in it. You wouldn't make an antenna out of resistance wire. Also, would you make your antenna out of lead pipe? Of course not. It's real heavy, and it's got a lot of resistance in it. And that's pretty obvious to any antenna builder. I wouldn't use either of those materials, those metals, to build the metal parts of my antenna. Well, here's one of my projects that I speak on quite regularly: magnetic loops. And it's a 4-foot square magnetic loop. Square, by the way, is the most efficient shape, I feel, for a magnetic loop. And it has a tuning capacitor. It's made out of aluminum foil. But in this particular loop that we just saw, and I'm not going to go into the details of that loop, I have a whole other presentation on magnetic loops and that one in particular. But in building that loop, I learned a major lesson about the plastics used in that loop, because that particular loop uses PVC plastic with aluminum foil on the surface, and takes advantage of the fact that all the RF runs on the surface, and you don't need to build magnetic loops out of solid metal to make them work well. PVC plastic covered with aluminum foil works just as well as solid pipe. But my good friend Rob Janke, K0XL, and Denny, K5DCC, we learned a big lesson about the plastics used in building antennas. There are two kinds of plastics, and this is we're getting into a little bit of organic chemistry here. Not seriously, but enough this is important. There are two kinds of plastics. In fact, there are two kinds of many molecules: polar and nonpolar molecules. And there are polar and nonpolar plastics. And all plastics are not the same. And you shouldn't build your antennas out of just any old plastic. Just as there aren't any old metals to build antennas out of, the nichrome and the lead aren't metals to build an antenna out of, neither is any kind of plastic the right plastic to build an antenna. Yes, plastics are insulators, but not all of them are good when you put them as part of an antenna, because they vary a lot in what's called the dissipation factor, the DF, or it's another way of measuring it is called the loss tangent. The delta of the plastic varies a great deal. Now, I began to hear of this years ago when somebody said, don't use PVC to build antennas with. Because PVC is not a good RF plastic, and that is indeed true. You can use it to build antennas with, but you need to be more careful about where you use it in an antenna. Yes, it's an insulator, but it's not as good an insulator to RF as you may think it is. Okay, what's a polar and a nonpolar molecule? Well, let's take a real common example: water. Water is a molecule, hydrogen dihydrogen monoxide, if you want to give a more technical name to it, H2O as we know it, 2 hydrogen atoms and an oxygen atom. Because of the way these 2 hydrogen atoms bond to the oxygen atom, it is not symmetrical. You can see that the 2 hydrogen atoms make their bond with the hydrogen atom, with the oxygen atom, non-symmetrically. They stick onto the oxygen atom off to one side, which causes one side of the water molecule to be more positive than the other side of the water molecule. It's polarized, in other words. It's a polarized or polar molecule. And the electrons, which flow around the outside of this molecule, and they share the outer orbits of the molecule, spend more time over in the oxygen atom, making that side of the molecule more negative. And when they're over in the hydrogen atom, just in the one electron over there, they make that side of the, they don't spend as much time over there, and therefore that side of the molecule is more positive. So a water molecule is polarized. Here, for example, is a plastic molecule, Teflon. We're used to Teflon. Its more technical name is polytetrafluoroethylene. That's its more technical name. And here's a kind of a representation of the molecule. It's a very symmetrical molecule. You can see it's a series of carbon atoms linked together with two fluorine atoms. So it's polytetrafluoroethylene, PTFE is its more technical name. And it's a non-polar molecule. And that's what makes it a good plastic for the use use in an RF environment. That's why it's very used in environments where it has to have good RF characteristics. Here's another good RF plastic, polyethylene. Now, polyethylene is a very common plastic in our modern world. Plastic bags are, simple plastic bags that we have. Lots of plastic bottles are made out of polyethylene. Not the clear ones, but the more milky looking kind of ones. And the basic molecule called the monomer, which you see up at the top, is a very simple molecule. 2 carbon atoms linked together in one way, and 4 hydrogen atoms surrounding the 2 carbon atoms in a very symmetrical way, making it a non-polar molecule. So it doesn't have one side that's more positive and one side that's more negative. It's all one way. It's non-polar. And when this simple monomer fuses together to form polyethylene, a whole bunch of those monomers at the top linked together, as we see here at the bottom, it forms a long chain or a plastic, a polymer. It still stays symmetrical and is a non-polar plastic and is a good plastic to use in an RF environment, one of the better ones. Another good plastic to use in an RF environment is the more recently introduced water pipe that we may find at hardware stores called PEX, polyethylene extensible. That's what PEX stands for, but it is polyethylene. As we saw a minute ago, polyethylene is a good RF plastic, and it comes in 2 versions as PEX, PEX A and PEX B. PEX A is the flexible stuff, which is good for pushing around in home environments. And PEX B, which is more rigid, and that might be more useful in building antennas with. It's still not as rigid as PVC pipe, but it's more rigid. And if you're building antennas with, you're more likely to use PEX B. You can often get straight lengths of it at the hardware store. Unfortunately, though, it doesn't come in the same sizes as PVC pipe. I wished it did. It doesn't come in scheduled sizes like PVC does. But if you want to straighten out that PEX B, by the way, and take the curve out of it, just stick it inside of a metal pipe and let it sit out in the sun for a few days, and it'll straighten itself out. Polypropylene is another good 3D plastic, and if you're a 3D printer, I own a 3D printer. I love 3D printing. I print a lot of things. A lot of things around my house are 3D printed. Polypropylene is the one plastic for 3D printing that is the best RF plastic for printing with. So if you're a 3D printer, consider getting some polypropylene filament for printing plastic parts that you might use in an antenna. And it's a very symmetric molecule too. as you can see, the hydrogen atoms are all on the outside. And when the polypropylene monomer links together, fuses together to make the polypropylene plastic, it's a very symmetric, very non-polar molecule. So polypropylene for 3D printing, it prints very well. In fact, it prints so very well that it doesn't tend to stick to your hotbed very well if you're a 3D printer. That's the base bed on the 3D printer. But if you do print with it, you may need to put some extra brims around the brims are a ring that you can print around the outside of your material. I'm speaking to you people who might be 3D printers. You need to print some extra brims or put some hairspray on your hotbed. Or another way you can make it stick to the hotbed is to get some of the polypropylene clear packaging tape. Scotch 375 is the 3M Scotch polypropylene packaging tapes. You can put that on your hotbed. If you're not a 3D printer, just ignore what I'm saying here. But some of you might be 3D printers, and 3D printing filament in polypropylene is the thing to print things out of that you might use to make antennas with if you're printing things for antennas. Now, heat shrink tubing. Heat shrink tubing is a good material to use in making antennas with. So if you're making antennas and you want to use heat shrink tubing for various reasons, it is a good material. I'm going to give you a table here in a few minutes, a couple of minutes, which you can get by just downloading my slides here, which are available to you. And it'll show you which plastics and which adhesives are good to use with antennas. By the way, if you have items that you put in a microwave oven, most of the ware that you put inside of a microwave oven is made out of polypropylene. That's what makes it safe in a microwave oven. And by the way, a microwave oven is a very good way to test a plastic. Take a piece of it, put it in a microwave oven, and if it melts, it's a bad plastic to use to make antennas with. So just because it's plastic, don't think because it's an insulator, it's good in an RF environment. It isn't. Some plastics are good, some plastics are terrible. And I'm going to show you a bad example in a minute that we learned from. Okay, so a polar plastic is non-symmetric. As you can see, here's the monomer, or the basic molecule that makes up PVC. When you string a whole bunch of these together to make polyvinyl chloride or PVC pipe, it makes a non-symmetric molecule, which will heat up in a RF environment and melt, in fact. So that's why PVC is not a good plastic to be used if it's subjected to the RF in your antenna. Now, if it's inside of aluminum foil, then it's not subjected to the RF. Then you can use it in the antenna, like in my magnetic loop, where aluminum foil covers it up. Then it's no problem inside of the aluminum foil. But if it's on the outside, where it's experiencing the RF, it's not a good plastic to use for an antenna. Now, here's a polar plastic. Hot glue, for example. Some of you might think, oh, hot glue, that's an insulator, that's a plastic. Hot glue is not a good material to be used in building antennas with, because it's non-symmetric. It's got that hydrocarbon molecule there on the outside of the symmetric molecule, making it not a good thing. So if you're thinking about using hot glue in building your antennas, think again. It's not a good adhesive to be using on building antennas. I'm going to show you which adhesive to use. So adhesives and plastics, just because they're insulators, doesn't mean they're necessarily good when you're building an antenna. The reason is that they have loss. The nonpolar plastics and the nonpolar glues have a lot of resistive loss in them, which can be rated in one of two ways, either called just loss factor, dissipation factor, or loss tangent. They can be rated on the internet. If you look up the loss in various plastics, you'll either get a rating either as loss tangent or dissipation factor. And the loss tangent, DF, might be what you'll get if you look up the loss in a particular plastic, or you might get the loss tangent. They both are the same thing. It's just a different way of rating the same thing. You want both of them to be low if you want to use it to make an antenna. Here's what happens. If you put a polar plastic in an RF field, such as inside of a capacitor, and it's the same thing that happens inside of a capacitor in the dielectric. This is why good capacitors have plastic as a dielectric that's non-polar. Here's what happens if you put a polar plastic inside of a capacitor or in a part of an antenna where the field is intense. The polar plastic there on the left is all the molecules are all lined up in a random way, as you can see on the left, with no field. But as soon as you put the field on them, it takes up some of the energy out of the field to line up the molecules. They have to be lined up. Now, if it's a non-polar plastic, it doesn't matter. They don't have to be lined up. But if it's a polar plastic, they have to be lined up. And so it sucks out some of the energy from the RF field and heats up the plastic. That's why the polar plastics are not good in a magnetic field. And PVC is not a good plastic because it's a polar plastic. Now, here's a useful table. You want to get this table and you want to keep it if you're building antennas using various plastics. You can get this table, as you can see, by just writing down. You don't need to write any of the rest of this down. Just write down what's on the right of this slide, w6nbc.com/slides. And this whole presentation will come down to you. And you can get this table and it'll show you the value of various plastics, whether they be glues or whether they be actual plastics. Now the blue stars in this table that I show over here, these blue stars right here, are the glues. Epoxy. Whoops, go back up here. Sorry about that. The blue stars are the glues: silicone sealant, hot glue, and epoxy. Notice which ones are good. Hot glue and epoxy are not good glues to be used if you're building antennas with them, if that hot glue and that epoxy is in part of the antenna where the field is heavy. If you're going to use a glue in an antenna where the part of the antenna that you're using it in, the field is heavy, you want to use silicone sealant. What's silicone sealant? It's that smelly stuff that comes in a tune, sometimes called RTV. It smells acidic. It smells like it smells like vinegar. It's acidic. That's the glue. It's strong. It's a bit rubbery, but it's a strong glue, and that's the glue to use if you're going to use glue in an antenna where the field is strong. If the field isn't strong there, then you can use epoxy or hot glue. Now, if you're a 3D printer, the good plastic to print with is polypropylene. I've already pointed this out. But the bad plastics to print with are ABS and polylactic acid, or PLA. These are the bad plastics. Mylar is not real good. It's not real good either, but it's better than the others. So the bad plastics are ABS and PLA, so forth. Acrylics, the plastics that you might buy that aren't real good either are PC board. PC board's not a good material to be used to be building antennas with. Acrylic plastic and plexiglass, not real good plastics to be building antennas with. and nylon. You might think, oh, nylon, that's a great material to build antennas with. Not if you're going to put the nylon in an RF field. I'm going to show you a real bad example that got me onto this topic here in just a second. So this table is very useful. The table is very useful. Look at the ratings over here of dissipation factor comparing these things. Up here at the top is Teflon, which is probably the very best of all the factors, very lowest loss if you put it in an RF field. It's why it's used in very applications where or high RF field as a dissipation factor of 0.001. Look at nylon down here at the bottom. It has a dissipation factor 360 times worse. Look at PVC. It's 170 times worse than Teflon. Hot glue is 150 times worse. Lexan, you know, that the real tough plastic, polycarbonate, is 100 times worse. Some of these other plastics aren't too bad. High density polyethylene, or PEX, is only 5 times worse than Teflon. So this table is a very useful table if you're thinking about using plastics to building an antenna, and the plastic that you're using is going in the high RF field part of your antenna. So just because it's plastic, don't think you can use it anywhere in an antenna. Okay, here's the eye-opening example that got me onto this topic. I kind of was aware of it for years when somebody told me years ago that PVC isn't any good for building antennas. Well, that's a generalization. It isn't any good for some parts of an antenna. Some parts of an antenna, it's fine, but other parts, it isn't fine. K0XL, a good friend of mine, built this interesting little mag loop out of 5/8 inch, I think it was, 5/8 inch outside diameter soft copper tubing. It probably could have been a little bit bigger for good efficiency in a mag loop, but anyway, we won't talk about that here. And what he did is on his 3D printer, he printed this adjustable capacitor. Instead of using a vacuum variable or a tuning capacitor, he decided to make his own tuning capacitor. And it was a couple of 3D printed plates, both are pretty much the same. And on one side of the plate, he put a copper coating. It's a copper plate on the other side of this 3D, these two 3D printed plates. And then he put a nylon screw through the top and through the bottom. The one on the top was a major tuning screw, which brought the two plates back and forth and brought the two ends of the tubing closer and farther away from each other, and the two copper plates that were soldered to the copper pipe closer and farther away from each other to form the tuning capacitor, the two copper sheets, two of them. The bottom tuning capacitor, the bottom screw did the fine tuning, and the top screw did the coarse tuning. And he was able to tune both 10 and 6 meters with this little loop, just with this top tuning screw. Unfortunately, the nylon screw that he put that nylon screw right in the high RF field in between that capacitor, or right up there right in the RF field. This little screw down here wasn't a problem, but this nylon screw that went through was right in the middle of the RF field. When he fired this loop up, there's the nylon screw you can see, and there's the copper plate. There's the ends of the magnetic loop, and there's the copper plate. And the nylon screw went right through just above the copper plate, and the magnet and the field, the electric field between those two plates, but was intense right at that plate. And so he put power to this magnetic loop, 50 watts, what he put to this magnetic loop. And this is what happened. Surprise, surprise. For a little bit of time, that nylon screw melted and squirted out a jet of liquid nylon. Nylon has high dissipation factor, 360 times worse than Teflon. Now, if he'd had a Teflon threaded rod through there, it would have worked fine. But not nylon, because nylon is one of the worst RF plastics, twice as bad even than PVC. So what I did here, this is just to show you, to illustrate this to you. I took a piece of polypropylene 3D printing filament. This is a piece of polypropylene, which is a good RF plastic, and a piece of polylactic acid, or PLA, 3D printing filament, which is not a good 3D printing plastic. And I put them in my microwave oven, and this is a piece of paper towel. I gave it about 3 minutes in my microwave oven, and then here's the paper towel afterwards. As you can see, the polypropylene heated up just a little bit. And here's the fact you can tell down there on the paper towel. But the polylactic acid, or the PLA, almost caught fire in my microwave oven. This led me to realize that I needed to make a change in my 4-foot diameter magnetic loop and replace the top pipe with a PEX pipe. I haven't quite finished the engineering here because, unfortunately, PEX isn't quite the same size as PVC. Now, the PVC pipe down here that was covered with aluminum foil, not a problem, because it's not in the aluminum foil removes the PVC from the field of the loop. But up here, where I had a sliding capacitor inside of this pipe, the PVC was subjected to the field and would have melted. Well, if I made this loop with PVC in the top, it would take about 100 watts, but that was the most that this magnetic loop would take. On the outside, where I used a band tuning capacitor on top with the same technique, I could replace that with low density polyethylene bottles to correct it. I haven't finished the engineering of that loop, but that's what I've been doing. So PVC is okay if you keep it out of the RF environment, such as wrapping it in aluminum foil and using it for pipes. But ABS, stay away from it. It's a particular no-no for building antennas with. Why? Because it's got carbon in it. What's the carbon for? That's to make it UV resistant out in the sun. So if you're going to build an antenna, a particular no-no, above all the rest of the stuff that I've been showing you, is the black, what's called drain waste vent pipe. When you go to the hardware store, you'll find ABS pipe and PVC pipe. The black stuff is ABS pipe, and it's not the ABS that's so bad. It's the ABS that's got carbon in it that's used as drain waste vent pipe. And the carbon is in it so that it can be placed outside in the sun and won't deteriorate. It's terrible pipe for building antennas with. Don't use it. So here's the takeaway for you. Avoid plastic pipes. Avoid the bad stuff. If the field is intense. Example, inside a Magloop's pipes covered with foil, there isn't any field, so you don't need to worry about it. Takeaways. PLA and ABS, PET, and nylon, bad. PVC, plexiglass, acrylic, PC board, bad. Good, polyethylene, polypropylene. Bad, hot glue and epoxy. Good, silicone sealant. There's your takeaways for you. So when you're building antennas, don't think any plastic's as good as any other plastic because it's an insulator. That's as dumb as thinking you can use lead pipe and nichrome wire for the conductors. That's just as stupid to say that. Both of them are bad choices, there are good choices and bad choices, both in the conductors and in the plastic. And you needn't forget that. So if you wouldn't use nichrome wire for an antenna, don't think that you can use all plastics and glue either. And that's it, folks.
Hey, John, this is Jerry. Did you notice?
How do you stop share?
around?
There should be you may have hidden it, but there should be something you can hover over, and I can maybe force that.
I'm familiar with Zoom. I'm not familiar with this presentation method.
I'll just take over, and I think it will force it to unshare, and then I will stop sharing.
There you go.
Or, I guess
still there.
You'll need to probably bring up your Edge browser again. It will freak things out from our end. It will make a mirror for our end, but you'll bring up your Edge browser, and there should be an option in there. Very bottom of the middle of the screen, just to the right of the search box, that one right there. Yep. And then if you see, there was like a little toolbar. If you scroll over just a little bit to the right, that one right there. The green and blue one, sorry. That one. We're still seeing your desktop, but that one that you just clicked on should have the option to stop sharing. Yep, as you're hovering over it now, you can see that there's... Let me see if I can force it. No worries. We appreciate the help, though. While you're playing around with that, did anybody have any comments or questions? Or I think Jerry, you maybe had something while he's messing around with that.
Yeah, John, the latest QST, did you see the article in there? It kind of caught my attention. A guy takes a piece of...
yeah, it's a spoof. It's an April 1st spoof.
Yeah, of carbon fiber, and cuts a slot in it, puts it over
that's a total April. Notice that it's in the April issue. That's a total spoof.
Total spoof? That's a spoof, huh?
Oh, it's a total spoof.
Yeah,
that's
I wonder.
That's an absolute hogwash.
Yeah.
Also go on a few more paces and look for the snappy training Morse key. It's in the new product. That's another spoof that's in the same issue.
April. Yeah. I wonder for really, April Fools, because
really cute.
It is cute. So
yeah.
I built the guy out there in California, I can't remember his name, that we had him for a presentation, and I built one of his 220 antennas, and he what's the other than the black pipe you're describing, are there two different kinds of white pipe? Because he recommended you use a certain one. I can't remember what it was, that you'd get at a hardware store.
The only two types of usable pipe at the hardwares. The white pipe is all PVC, polyvinyl chloride, and it's all not a good plastic in an RF environment.
Right.
ABS is terrible. Don't ever use the black pipe. For building antenna stuff out of.
But I was thinking that there was two different white pipes that was available, like at Home Depot, and he said use this one, and I can't remember.
The only other white pipe I know of at Home Depot is the PEX. PEX.
No, it wasn't. This was kind of before PEX, but anyway, okay, we'll figure it out. Appreciate it. Yeah, Orland.
CPVC. CPVC.
Yes, CPVC.
Okay, CPVC.
CPVC is very similar to PVC. It is a PVC. Yeah, I forgot about CPVC.
Okay.
Yeah, I didn't list it, but it's not any better than regular PVC. It's a polar plastic too.
What do they use on the the commercial antennas that you see? You buy from any of the antenna manufacturers, the radome on it. Do you know what it is?
That is fiberglass.
It is fiberglass.
Fiberglass is fair. Fiberglass is fair.
Okay. Yeah, would be fiberglass, because when it wears down, it eats your eats your skin.
Oh yeah,
I've got. I have a couple of those, like one was an X50 and then sort of an X50 clone that were the radome was busted by a forklift operator over at the Salvation Army warehouse. So I have the innards on. I'm going to get some pictures of those and put them in the round table where you can see what so-called magic is inside of those, why they'll work on 2 meters and 70 centimeters. Also, the one you were talking about that is 2 meters, 220 and 70 centimeters. He did some tricks in there that, after looking at that, I think that what he's made is a 3-band dummy load that just happens to be out in the clear and somewhat radiates.
Okay. Yeah. Okay. All right. Any other questions out there for John, or in general, antenna wise, or anything else that fits here?
Okay, well, it's fine. Sorry
All
for
right.
that. Sorry for my inexperience with Google Meet. I have only used it a couple of times before.
Well, you're not the first one that's stumbled with it, so don't feel that.
I was going to say, anecdotally, anecdotally, ice doesn't melt in the microwave. I know that doesn't necessarily have anything to do with what you're presenting, but that's another kind of just icebreaker kind of information as well.
Okay.
Well, I guess if there's nothing else.
All the best to you guys. Well,
thank you.
See you all down the line. And
we'll look forward to that.
Need another talk, I'm here anytime.
All righty, John. Thank you. We'll look forward
73 to you.
73 to you.
Take care.
Well, has anybody got anything they want to talk about? We're came through that pretty early, or if not, we'll just kick you loose and enjoy the rest of the evening. Hearing nothing, I guess that's well. I don't think we got anything I don't see anything in the chat, do we? Doesn't look like. Was there something there? Yeah, let's see.
Just some thanks.
Maybe just.
And if someone did want to see the Snooper probe presentation, I pasted that in. It's on our YouTube channel, and he's also presented it to other channels as well. So the initial presentation is available online in plenty of places.
All righty. Hey, Orland, hang on a minute when we talk to you for a second. So I guess we're pretty much done. Thank you, everybody. Appreciate it.
Have a good evening.